Good day. This is Miss Mayan Mangito Lapis, and I am going to discuss to you about plate boundaries and other processes. Welcome. Are you excited for a fun learning session?
Today, you will learn about the types of plate boundaries, the types of convergent boundaries, the plates that lie on the different types of boundaries, the possible causes of plate movement, and the process of convection current in the mantle.
Are you ready? Let me take you to an adventure.
So there are four layers of the earth. The one on the surface is the crust, the thinnest part of the earth's interior. And then we have the mantle after the crust. And after the mantle is the outer core. And then the innermost part of the earth's interior is the inner core. Now, according to the iron catastrophe theory, there was a sorting of materials by density, wherein the same parts of materials, the densest sank towards the Earth's core. Okay, this is mostly iron. So lahat ng iron, lahat ng mabibigat na metal elements ay lumubog papunta sa gitna. Okay? While the silicates were displaced towards Earth's surface. Yung mas magagaan na elements ay napunta doon sa surface ng Earth. In this type of process, this is how our planets was formed. It is moving round and round, accumulating materials from the outer space. Habang umiikot ang planet or ang planetoid na to, na-form siya into a planet, lahat ng materials na makukuha niya from the outer space ay nagsama-sama at nag-sort. Ang mabibigat or ang densest ay napunta sa gitna at ang pinaka magagaan na materials ay napunta sa surface ng planet. And now, our planet looks like this one. But before, during the Permian period 225 million years ago, there was what we call Pangaea, or there was only one continent, a big mass of land. Then after 200 million years ago, during the Triassic period, when this kind of organisms or animals were living, there were only two continents due to the plate movement or paggalaw ng mga plates na ito or ng lupa na ito. Those two continents were called Laurasia and Gondwana. 135 million years ago, during the Jurassic period, that was the time the dinosaurs existed. The plates move once again. So, the plates moves away from each other and the continents looks like this. After 65 million years ago, this was Cretaceous period, and if I'm not mistaken, there are already mammals. That time, the continents looks like this one due to the movement of the plates. Why do plates are moving? And now, this is our world map, where we can distinguish the continents such as North America, South America, Antarctica, Africa, Europe, Middle East, Asia, and Australia and Oceania. Again, the question is, why do plates are moving? Because of the movement in the mantle, there are movements of plates that are occurring. There are actually three types of plate boundaries where movement occurs. The first one is divergent plate boundary. The second one is the convergent plate boundary. And the third one is the transform plate boundary. Now let's talk about diverging or plates or the divergent boundary. Divergent boundary is a fault where the two plates are moving away from each other. Look at this illustration. So, as pressure from the mantle occurs, two plates are moving away from each other and fault valley can be formed, like when you look at it closer. The African Rift System is another example of divergent plate boundary, and the Benham Rise. The Benham Rise here is an island near the North Luzon, which is a result of diverging plate boundary. Let's see what will happen if there is a young ocean crust and old oceanic crust. What will happen if we will move them apart? Okay, look. So as you can see, they are diverging or moving away from each other. Let's see what will happen after they move away from each other. So as you can see, this was labeled as young oceanic crust because from the mantle, as mantle convection happens, materials goes up and the young oceanic crust replace the old oceanic crust. Ibig sabihin, napapalitan ng materials from the mantle ang mga old oceanic crust. Okay, ngayon, ang mga materials na galing sa mantle ay nagiging parte ng young oceanic crust. A convergent boundary is a boundary where two separate plates are pushing into each other. For example, there is an oceanic crust and continental crust that are moving towards each other. The denser crust will go beneath the less dense crust. So the oceanic crust will subduct or goes beneath the continental crust. And as it goes down or subduction occurs, the rocks, the soil, the materials from oceanic crust will be melted, and this will create pressure that causes the material from the mantle to rise up and form volcanic arc or volcanoes in the future. This is another examples of an illustration of a subduction zone. So you can see this oceanic floor or oceanic crust goes beneath the continental crust. And once again, this creates pressure to the mantle because of the mantle convection. So the mantle convection makes the material from the mantle to rise up, and these materials will cause, maybe a volcanic eruption or a formation of a volcano. In convergent boundary, there is a high seismic activity or malakas na paggalaw ng plate. This can cause reverse faults. In the Philippines is an example of convergent boundary and an island arc. The mountains, volcanoes, and trenches all can occur along convergent boundaries. Two colliding continental plates do not always cause volcanoes. Now let's put a continental crust and an old oceanic crust. This is the lithosphere. This is the mantle. Let's move the old oceanic crust, and as you can see, the old oceanic crust goes beneath the continental crust or pumupunta sa ilalim ng continental crust. And while it is moving or subducting, this is what we call the subduction zone. And the process that is occurring is the subduction. The mantle here, or the materials in the mantle, rise up and creates or form another landform, which may be called volcanoes. This is what happens when there is a converging boundary. This is what happened in a convergent boundary. If there is a subduction, volcanic arc and chain of volcanoes may occur. When there are converging two oceanic plates, an island arc can be formed. When there is an oceanic plate that is going towards a continental plate, a continental volcanic arc may occur. When there are colliding continental plates, to continental plate subduction, just like in Himalayan mountain, Mount Everest, in Indian and Eurasian plate, this can cause, or this may be result into the formation of collision of mountain belts, reverse fault, or earthquake. So this is what I am talking about earlier. This is the Himalayan mountain. Now let's talk about the transverse plate boundary, or the transform plate boundary. So in transform plate boundary, two plates are moving sideways. The crust is broken, but no materials created nor destroyed. Now let's put two continental crusts. Let's label them. Okay, so there are two continental crusts. This is the lithosphere and then this is the mantle. Now let's move the navigator like this, sideways. This is what we call transform plate boundary. Now let's place an old oceanic crust and a young oceanic crust. So let's label them and color them. Let's show the sea water also. Alright, so there's a young oceanic crust here and old oceanic crust here. Here's the lithosphere and the mantle. Now let's move them this way. Okay, so what I did is an example of oceanic crust transform plate boundary, just like in San Andreas Fault. So this San Andreas Fault is a transform plate boundary. This is the link between ridges of Southern California and offshore of Northern California. This is the Ring of Fire. So as you can see, this Ring of Fire is a path along the Pacific Ocean characterized by active volcanoes and frequent earthquakes. And as you can see here, nandito ang ating bansa, Philippines. Okay, so ang Philippines ay nakaka-experience ng mga earthquake ng maraming beses sa loob ng isang taon at volcanic eruptions din. In fact, we have a lot of volcanoes, and that is because of our location. Its length is approximately 40,000 kilometers. It traces boundaries between several tectonic plates, including the Pacific, Juan de Fuca, Cocos, Indian, Australian, Nazca, North American, and Philippine plates. This is the Philippines map of volcanoes. All the red dots are the places where we can find the volcanoes. 75% of the Earth's volcanoes, more than 450 volcanoes, are located along the Ring of Fire. 90% of Earth's earthquakes occur along its path, including the planet's most violent and dramatic seismic events. As you observe also, the volcanoes formed on the east side of the Philippines, and that is near the ocean, the Pacific Ocean. And that is also because of the Philippines is located on the Pacific Ring of Fire. Alright, so that's all for today. I hope you learned something. Until next time, thank you.